Hi, my name is Walker Gallman, and this is my video covering Public Lecture 2 for Physics 2211. The 2024 Nobel Prize in Physics was awarded to John Hopfield and Geoffrey Hilton for their groundbreaking work in artificial intelligence. Their contributions have profoundly influenced fields like physics, neuroscience, and even modern engineering disciplines like mine, aerospace engineering. I recently attended Public Lecture 2 on this topic, given by Professor Audrey Sederberg. It was an eye-opening discussion about the history, scientific significance, and future implications of their work. Today, I want to share what I took away from this lecture and reflect on how it connects to my field of study here at Georgia Tech, aerospace engineering. One of the most fascinating concepts I learned about was Hopfield networks and their use of an energy landscape model to store memories. The analogy of valleys in a hilly terrain representing stable memory states made this abstract concept much clearer. It was also interesting to learn how these networks link to statistical physics by calculating the maximum number of patterns they can store before errors occur. This made me realize how much physics underpins AI. I've always thought of AI as a primarily computational field. However, this lecture helped me appreciate its deep physical roots and how interdisciplinary the field truly is. I came into the lecture with some knowledge of neural networks, particularly how they are modeled on biological processes in the brain. However, I hadn't fully appreciated the historical context. Professor Sederberg highlighted early neuroscience work by Santiago Ramon y Cajal and others, which laid the foundation for how neural networks integrate inputs and outputs. And here pictured are works from Santiago Ramon y Cajal. Hearing this made me reflect on how foundational ideas from one discipline, like biology, can inspire groundbreaking advancements in others, like computer science. It also gave me a new perspective on the importance of building upon previous research when tackling modern challenges. What stood out most what stood out most was how these ideas have evolved into modern machine learning systems, like restricted Boltzmann machines and deep learning models. These systems now power everything from image recognition to autonomous vehicles. I find myself particularly curious about the parallels between neuroscience and AI. For example, the lecture discussed how advances in neuroscience, like recording activity from thousands of neurons at once, are helping us understand processes like visual recognition. It also made me wonder what other insights from neuroscience might revolutionize AI in the future. As an aerospace engineering student, I saw many connections to my field. Machine learning is already transforming aerospace technology, from optimizing flight paths to enabling autonomous drones. Neural networks are also a key component of these systems. Neural networks are a key component of these systems, helping to analyze complex data in real time and to make decisions. The lecture also got me thinking about how these concepts might apply to spacecraft design. For instance, could AI-driven systems predict and adapt to environmental changes during space missions? Also, uh, might they enable more efficient simulations of fluid dynamics for aircraft? After the lecture, I spent some time exploring AI applications in other scientific fields. For example, AI has been instrumental in detecting gravitational waves, identifying exoplanets, and even improving early earthquake warning systems. These examples made me realize how universal these technologies have become, providing tools to address some of the biggest challenges in science and engineering. It also made me consider the ethical and societal implications of these technologies. With AI's growing influence, how do we ensure it is used responsibly? Also, how do we balance innovation with oversight? These questions feel especially relevant as we integrate AI further into critical systems like aviation and space exploration. This lecture was a powerful reminder of how interconnected science is. Foundational work in one field often sparks progress in others. The intersection of physics, neuroscience, and AI exemplifies this beautifully, showing how we can better understand and solve complex problems by bridging disciplines. As an aerospace engineering student, I'm inspired to think about how these ideas might push the boundaries of my own field. Whether it's developing safer autonomous aircraft or enabling more ambitious space missions, the possibilities are honestly endless. This experience reinforced the importance of staying curious and exploring beyond the boundaries of my discipline. Thank you for listening.